In this lesson, we'll continue our review of Math Test 8, Section 4, Calculator Permitted, questions 31 to 38. We're on the start of the grid-ins, so we know the difficulty level resets. 31 is going to be a much easier question than 29 and 30, the last few problem solvings. All right, let's take a look at the first one. There are 2 atoms of hydrogen and 1 atom of oxygen and 1 molecule of water. How many atoms of hydrogen are there in 51 molecules of water? And so in 1 molecule of water, we're told that there are 2 atoms of hydrogen and there's 1 atom of oxygen. And the question, so we know there's 2 atoms of hydrogen and 1 molecule of water, so how many in 51? So we really just have to multiply by 51. So it's just going to be 51 times 2, and the answer is 102. And for oxygen, that would just be 51. All right, let's take a look at question number 32. If x equals 1 in the equation above, what's the value of a? So if we just plug in a 1, and I'm going to add 1/2 a to both sides. And to solve for a, we just multiply both sides by 2, and we get a equals 2. So another very straightforward question. All right, let's take a look at question 33. In the xy plane, the equations x plus 2y equals 10 and 3x plus 6y equals c represent the same line for some constant c. What is c? Now, same line, that means that these 2 equations are equivalent. Another way of thinking about that is they have infinite solutions. They really are the same line. They're right on top of each other. So we have to just make them the same. So the first one is x plus 2y equals 10. 3x plus 6y equals c. And if you notice, if we multiply this top equation by 3, we get the 3x, we get the 6y, and so we have to just multiply 10 by 3 and 30. This would make these equivalent equations, and that's the answer. All right, let's take the last one. Again, these are pretty straightforward, these first 4 grid-ins. On April 18th, 1775, Paul Revere set off on his midnight ride from Charlestown to Lexington. If he had ridden straight to Lexington without stopping, he would have traveled 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of a mile per hour? And so this is a rate question. If he had ridden straight through 11 miles in 26 minutes, so we're going to set up a proportion, 11 miles and 26. Okay, so just remember, top we have miles, and on the bottom we have minutes. And we have to figure out his speed per hour. And so the first step is, let's figure out this rate based on minutes. We know there were 60 minutes in an hour. You can see how many miles at this rate he would have traveled per 60 minutes. And so we just cross multiply. We get 26x. And that's going to be divided by 660. So 660 divided by 26. And this gives us 25.38. So this is his expected distance per 60 minutes, which is per hour, but read the question carefully, the nearest tenth. So just to review, when you have the decimal point and you're moving to the left, these are called units. This first one are ones, and then the second digit over, this is called tens and hundreds and so on. Now as we're moving to the right, this first digit is called tenths with a th, tenths. And that's what the questions ask for. So we need to round this to the nearest tenth. So 0.38 is going to round up. And so the answer is 25.4. So just read these questions carefully on the grid, because you don't have any recourse with the answers. If you make a mistake, then there's no check on that.